Hi, I'm Dr. Rob Stevenson, and I want to welcome you to WKAR's new workshop series, The Curious Crew Roadshow. I'm busy working on new episodes of Curious Crew, so Mrs. Pizzo will be your host for this virtual event, featuring fun and exciting science, technology, engineering, and mathematics investigations. And of course, the Curious Crew is ready to tackle these investigations with her. So let's get started. And remember, my friends, stay curious and keep experimenting.
Learning in Michigan has changed. The Michigan Learning Channel now allows learning from anywhere. On air, online, on demand, and it's all available statewide for free to students, parents, and teachers from Michigan's public television stations. For more information, visit michiganlearning.org.
Welcome to WKAR's Curious Crew Roadshow. I'm Mrs. Pizzo, and I'm so glad you're here with us today. I'm also glad to have members of the Curious Crew with us. Say hello, Curious Crew.
Hello.
Hello.
Great. How about you introduce yourselves and tell us your grade?
I'm Jacob and I'm in 8th grade.
I'm Sasha and I'm in 8th grade.
Hello, I'm Rashab and I'm also in 8th grade.
Now we're going to play a game. Let's see if the Curious Crew can name a type of bubble without repeating someone else's. Rashab?
Bubblegum.
Bubble tea.
Bubble wrap.
Those are all different types of bubbles, right? I was also thinking of air bubbles. I hope you're ready to explore more about bubbles with the sudsy STEM investigation. What do you think we're investigating, Sasha?
I think we're investigating bubbles.
That's right. We're going to explore bubble science.
Hi, I'm Rob Stevenson, and this is
Curious Crew!
That's right. Welcome to the show, everybody. We always like to start with a couple of discrepant events because discrepant events stimulate
Curiosity!
That's right, and I've got some fun ones ready. In fact, Adia, can you do me a favor? Can you put your hand out just like this? Do me a favor. Can you hold this bubble for me? Just hold that. Come on, Adia. Let's try again. Just hold. Okay, let me give you another. That was right in your hand. Okay, Ty, get your hand out here. Get your hand out here. See if you can hold that. Oh. Okay, do me a favor, both of you guys, put on one of those gloves. And let's try this again, okay? Oh, nice. Whoa, okay, questions? Isn't that weird?
How does the glove keep it from popping?
Isn't that strange? I'll give you another one. That is an excellent question. Oh, it's gonna be big. Wow, okay, you guys hold those. Now I've got something else here, and I have to be safe about this. We've got something called dry ice. So you notice we have the goggles, so safety first, let's get those on. And I'm going to put a chunk of this dry ice into this container of water. And I would like a prediction from one of you. What's gonna happen when we put dry ice into water? What do you guys think? Maya, what's gonna happen?
I think it's going to create a fog.
Create a fog. Awesome. Okay, you guys wanna see? Let's take a look. Let's put this in there. Oh, boy. Now I'm gonna try something else. I've got this rag that's all wet, and I'm gonna get the lip of this wet. Now I'm going to attempt to get a film going across the top of this. Adia, if I can do it, what might happen?
It's going to create a big fog bubble.
A big fog bubble. Oh, there we go. Check it out.
Whoa!
Isn't that? Don't bump the table, be careful. Let's see what happens. Oh, isn't that awesome? And it goes way down like that. Okay, pretty interesting phenomenon, don't you guys think? Okay, bubbles that you can hold, fog bubbles that explode. Anybody have a guess what we're gonna talk about today? What do you guys think? Maya, what do you think?
Maybe bubbles?
Maybe bubbles, good thinking. Now I'm gonna take this off for just 1 second. I would like 3 of you to try to figure out these two phenomena. So we're gonna do a little scientific modeling. Anybody wanna give this a try? Okay, Ian, Julia, Sasha, I'm gonna have you guys work together, see if you can develop a scientific model and use the information you learned through the show to try to explain these two phenomena. And you can try it at home. It's fun.
Are you curious about careers in science? Hi, I'm Genesis, and today I'm here with Julie Conkle. Julie, where are we and what do you do?
We are in the soap shop called Farm Suds, where we make soap and lots of other things too. I call myself a soap scientist because we make soap for different types of skin here.
How do you make soap?
When we make soap, we want to put on our safety equipment. Then we gather all of our ingredients. So here's our recipe.
Lard, coconut oil, olive oil, castor oil, goat milk, lye, and essential oil.
Once all of our ingredients thickens, that is when we can start adding our colors and our fragrances.
This one smells good.
Okay, good. I tell kids that are interested in my career that they need to like science, in particular chemistry. You need to be good at math and just basically want to help people.
I really cleaned up learning about soapy science with Julie Conkle. Explore your possibilities.
That was good, Drew.
Being on the set of Curious Crew is a lot of fun. It's definitely different than what you'd expect.
Cut for second audio.
Just make sure you're not moving around too much with the gloves.
Okay.
The production crew often tells you to smile, and when I say often, I mean about every 10 seconds.
Big smiles. Big smiles. And guys,
Yes.
smiles.
Yes.
We were told to always keep our energy high.
Finally!
And just to have fun while we're at it, because this is not something many people experience.
Jay, we're gonna have you say, yeah, like kind of respond to this.
Working with the production crew, it was definitely a great experience. We had fun.
And I got the smile. And I got that smile.
Are you curious about careers in science? Hi, I'm Genesis, and today I'm here with meteorologist Emily Walls. Emily, where are we? And tell me more about what you do.
Well, today we are at WLNS TV6 in Lansing, Michigan, and I am the weekday morning meteorologist.
What does a meteorologist do?
A meteorologist interprets data in order to explain and understand the weather. We look at weather models, which are based on mathematics and physics, and that's to analyze what might happen in the future. Watch this, it's like magic. When it looks like I'm standing in front of a weather map, I'm actually not. Every single time I turn to the side, I'm looking at myself in this side monitor. We have computers that turn everything that's green into my weather map.
On Monday, there is a 40% chance of rain with a high of 82 degrees and a low of 63.
You got it, you did so well.
Yay! After meeting Emily Walls, I'm forecasting a future in meteorology. Explore your possibilities.
Now we'll review the materials. We have bubble solution, a straw, and a large container. We also decided to have a cup of water also. Let's show a thumbs up, Curious Crew, if you're all set with those items. Great. Next, I'll review the procedures. Then our Curious Crew will get started on the investigation, talking us through their process. And remember, you at home can also complete the investigation and many others by visiting www.WKAR Curious Crew Curiosity Guides. We always remember safety first. So remember, wearing safety glasses protects your eyes. Great job, Curious Crew. In reviewing the procedure, the first thing you're gonna do is hold your hand over an empty container. You're gonna get your hand wet by pouring the bubble solution over it. While your hand is still wet, dip the end of the straw into the bubble solution. Then place the straw on your hand and gently blow through the other end to form a bubble on the palm of your hand. What happens if you move your hand? You can even try shaping your hand different ways to create different shapes and bubbles. If you curl your fingers and your thumb together, and then open the fingers into an okay sign, you can get a film that you can blow through to make another bubble. You're even going to ask yourself if you can completely blow the bubble and hold the bubble in your wet hand all together. All right, Curious Crew, you may begin. And remember, talk us through your investigation.
Bubble solution. Into the baking. There are some bubbles in the thing.
Okay, that seems about enough.
Now I just need to dip the straw in, and there we go.
My hand in.
A little bit more.
Nice, because it's hot out.
Does it feel super sudsy?
Yep.
Yeah, for sure.
All right, we want to make sure they're good and wet. Seems like Sasha is ready. Sasha, do you want to get started and try to see if you can blow your bubble? Yeah. I think it helps too if the straw is dipped into the solution.
There you go.
Wow, Sasha. All right, Jacob, seems like you're all ready to go. Did you dip your straw into the solution also? That makes it a little easier. Hold those hands straight out. Jacob's still working on his. All right, Rashab. Let's see. Jacob's still working on his. How we looking, Rashab? Oh, wow, Rashab's bubble. Wow, he's getting a huge bubble. Wow. All right, let's see. Jacob is still working on getting one. Now, have you tried to put your hand in an okay sign once you get that bubble and see if you can blow through? Let's see. Wow. So cool.
Went over the computer.
Jacob, you're a human bubble maker. Let's see, Rashab. Wow, that was a great big bubble, Jacob, coming right at us.
Whoa, it attached to like this thing. It attached to the plastic lid and it's on the plastic lid now.
Can you blow a bubble inside of the plastic container?
Oh, it popped.
Oh, wow. Look at that bubble, Sasha, and it's full of all of those iridescent colors.
Yeah, it's really pretty. It popped.
It popped. All right, let's try one more investigation really quickly. Now that we know you guys can make great bubbles and actually hold them in your hand, add a little water to your solution and see if you get even more bubbles. And that's going to help us determine what bubbles need to really take shape. Sasha is stirring hers up. Can you tell me what's your strategy between why you're stirring yours up?
I figure that when you have it just separate, then it would just separate the water and the bubble solution. So I'm mixing them together, and I'm already noticing that there's a bunch of bubbles in the bubble solution, even without blowing on it.
Wow, that's great. Now, was it easier? Wow! Those bubbles easily formed once you added even more water. Jacob! Do you think your bubbles make a difference if you blow quick or fast? Jacob, you got a bubble in hand. Sasha has about 3 or 4 bubbles. Rashab, wow. So what do we learn about adding water to the bubble solution?
When you add water, it makes the bubbles go better.
It makes the bubbles grow better. So what does a bubble need to actually form?
Definitely water.
Definitely water. Very good, Rashab. How cool is it? How fun is it to play with those bubbles?
It's really cool. I think the water especially helps the bubble solution because it makes the bonds between its own molecules stronger, and therefore it can grow large without popping.
That's right. That really is the science behind bubbles. I love Sasha's bubble is upside down. And doesn't it seem like the water has strengthened your bubbles, that they're lasting even longer?
Definitely.
Wow, Jacob has bubbles floating around his huge bubble. Wow, lots of bubbles jumping around his huge bubble. I think that's pretty cool. Nice job, everyone. This is certainly going to be popular, don't you think?
Yeah.
Yeah.
Now let's watch Dr. Rob's investigation, and we'll discuss after.
So I have something special for you guys because you have bubbly personalities. You guys ready? I have taken some lids from some glass pots, flipped them upside down, and we poured some bubble solution inside, okay? First thing we're gonna ask you to do, pick up a straw, and we're going to put it in the solution, and we're gonna start to blow a bubble, and as we do, we're gonna pull the straw up and back and see if we can make a bubble dome. Let's try it, okay? Awesome. Oh, gosh, Sasha, you did that so fast. Well done, you guys. Okay, while you're blowing that, Sasha, I want you to think about something. What'll happen if I touch this with my finger?
Pop.
It's gonna pop. How sad is that? But watch this. If I touch it with my straw.
Wow.
Isn't that interesting? Think about why that might be the case. What do you think?
Because it's already wet with the solution, so it won't pop it.
Exactly. Okay, so it's already wet with the solution, and so it sort of fills in the gap. It doesn't pop. Nice job. Okay, here's a fun challenge. Put another bubble inside. Make sure your straw is wet, and you can put another bubble inside the first dome. Oh, you got clusters going on over there. Good job. All right, I'm gonna have another little challenge for you too. This is an interesting one to try at home, but you might wanna do this one outside because it's a little messy. You ready? I'm gonna put my hand inside this bubble solution and I'm gonna get it wet. Oh dear, it's really slimy. Okay, I'm gonna hold it over the tray. I'm gonna grab my straw and I'm gonna see if I can get a bubble in my hand. Now remember, we were having trouble holding bubbles in our hands before, weren't you, Adia?
Yeah.
Sorry about that. Now watch. Watch what happens when I even open my fingers. Okay, you guys try this. Take your non-dominant hand one at a time, put it in there, and get it kind of wet. It's kind of slimy, which is fun. Hold your hand over your tray. See if you can make a bubble in your hand. As long as your hand is wet, we can keep this bubble going. Nice job. Adi, what are you noticing there?
When I spread my fingers apart slowly, the bubble, it flattens and it like spreads out even though it's still a bubble.
Awesome, so it hasn't popped yet. So what are you noticing, Finny?
I'm noticing that just like with the bubble dome, you can blow bubbles inside of this bubble.
That's right. But going back to what you said before, Sasha, as long as your hand is wet, we can keep that bubble intact. It's as soon as we touch something dry, I'm gonna be really mean, Sasha, I'm sorry. As soon as it touches something dry, is that it will pop. Try these at home, it's way too much fun. Remember, outside with bubbles in the hand. Bubbles are interesting, but they don't last very long before they pop. You've probably noticed that bubbles pop when they hit something dry or when the water begins to evaporate. But on a cold day, your bubble may last a little longer. This is because the molecules move more slowly in colder temperatures and can take longer for the water to evaporate. Sometimes the bubble can even freeze, lasting a bit longer. You might also see a blown bubble drift upward from the warm air inside the bubble being less dense than the surrounding colder air. Bubble liftoff.
Now, let's discuss characteristics of bubbles. Do you think you can name a few? I'll start. Bubbles pop when exposed to dry objects. How about you, Rashab?
Bubbles are soapy because of the bubble solution.
Very good. They are soapy. And Jacob, what do you think?
Bubbles have lots of colors moving in them.
Wow, that's a great one. They do have lots of colors. Sasha?
Bubbles are transparent, so you can see through them.
Yes, bubbles are transparent. You can see right through them. All of you had great responses. Bubbles are interesting, but bubbles don't last very long before they pop. You've probably noticed that bubbles pop when they hit something dry or when the water begins to evaporate. But on a cold day, your bubble may last a little longer. This is because the molecules move more slowly in colder temperatures and can take longer for the water to evaporate. Sometimes the bubble can even freeze and last a bit longer. You might also see a blown bubble drift upward. The upward motion comes because the warm air inside the bubble is less dense than the surrounding colder air. Bubble liftoff. Well, that wraps up this episode of Curious Crew Roadshow. I hope you'll join us next time, where inquisitive kids take a hands-on approach to investigating principles of science, technology, engineering, and math. STEM on the road. And remember,
stay curious
and keep experimenting. Bye.
Are you feeling curious?
Yeah!
Are you guys having fun this morning?
Curious Crew started when Susie Elkins saw me present doing a keynote, and she had a brainstorm.
I saw him get an award, and the parents treated him like a rock star. They just loved that he was able to inspire a love for science in their children, and it was that inspired me to want to make a show with him.
What do you notice?
Gosh, this is crazy.
What do you notice?
Being on the show with Dr. Rob is really cool.
Oh, that was awesome! I have a reputation of doing a lot of hands-on investigations.
Oh, yes!
A lot of the experiments are really simple stuff you'd have lying around in your kitchen or in a craft room.
And it's using those materials to teach these different concepts.
Oh, that was good! Ultimately, we want the kids to work through science and engineering practices, what scientists actually do to be able to understand the concepts that we're exploring.
You do a science experiment to see what happens, meaning a quote-unquote failure is also a result too.
Whenever we have a project like this and things don't go well, what would we do? Redesign it, absolutely right.
Being on Curious Crew made me realize that science is all around us.
Science isn't boring, it's fun.
We get some fizzy action! Rob's passion for science is contagious.
Dr. Rob has a lot of energy on set.
Energy in motion!
That energy, it transfers to the cast members.
Curious Crew has a roadshow element as well, and we'll go to schools, we'll go to fairs, we'll go to different events.
I didn't want it to just be 10 shows and we're done. I wanted the children that were involved with it to feel inspired and empowered to go out and talk about their love of science. And we've created curiosity guides, the lesson plan behind each of the investigations in the show. Parents and teachers can download them from the website and use them on their own.
It is awesome.
This show really makes science and engineering accessible, and it helps children realize that if this is something they're passionate about, they could do this for a lifetime. We can have a lot of fun with pulleys, don't you guys think?
Yeah! At the end of every show, we point at the camera and say,
Stay curious!
And keep experimenting.
There's so many ways that science touches our lives, and if you don't stay curious, you could totally miss out on those.
Remember, my friends, stay curious.
Stay curious.
Stay curious.
Stay curious.
And keep experimenting.
And keep experimenting.
That's gonna go at the end.